Hello friends, welcome you all. So in this lecture we will discuss some example of PDA creation, and I have listed some similar kind of languages here, and I will tell you for some languages out of these I will create PDA. So we will start with A and B N here, which is first context free language that we have discussed. So I will start with the A and B in here. So first of all, I will tell you the idea. And remember, friend, as I told you, you can create both type of PDA for any context-free language, like PDA accepting strings by reaching final state and accepting strings by by empty stack. So I will create in all these languages. I will create first the PDA accepting strings by empty stack, and then I will convert it to accepting strings reaching final states. So I will take both type of PDA example here. So I will start with the A and B n, where n is greater than or equal to 1. So first I will tell you the idea of for this particular language, and then we will start creating transitions. So I will tell you how we will be going to implement this. So initially there would be Z0, as I told you, Z0 is initial stack symbol. So now, from any string we are having here, like AABB, this is the valid string for this language. So, my idea is whenever we are reading A here, we will push one symbol X into the stack. And whenever we are reading V, so we will remove one X from the stack. So in this case, the number of symbol pushed into the stack and number of symbols popped from the stack, if both A and B, number of A and number of B are same, then after reading complete string, the only Z0 must be in the stack. Suppose we are for this string, we will push 2x as we are reading 2a here, and then as we are reading 2b here, so we will pop these 2x, and after completely reading this string, only the Z0 would be there in the stack. So in this way, we will ensure the number of A and number of B are same. So this would be the idea, and now we will make the transition according to this idea for that particular language. So I can take some example here. Suppose our initial state of the PDA is Q0. Initial state of PDA is Q0. So I'm on Q0 and I am reading A here. I'm reading A here, and initial stack top is, I'm creating a stack here, so which is initial stack top is Z0. So I can write it as Z0. Then in this particular situation, what we have decided, so whenever we are reading A, then we will push one X into the stack. Push one X into the stack. So here we will mention it like this. So we will stay in Q0 and we will push one X into the stack. So remember, friend, whatever current stack top is, we will also write this in the right hand side, and along with this we will write the symbol that we want to push into the stack. So we want to push one X into the stack, so I have mentioned here X, and along with current stack top. That means whatever is there into the stack, that will remain same. Additionally, we are putting one symbol there, X. So this is how you can mention it in transition. So whenever we are reading A, so we are pushing one X into the stack. So for first A, Z0 will be on the top. So then we will push one X into the stack. So I can push one X into the stack. Then we are staying again in Q0. So we in Q0 we will read A again, that you can consider as second A, then in place of Z0, now stack top is X. So we will consider this transition also. Now, in this case, we will push one more X into the stack. So I can stay in Q0. No. Then I will push one X here and current stack top we will write as it is. So this is how you can mention this transition. Now, any number of A's you can read with this particular transition. So now after all reading all A, we will start reading B. So on Q0, when we are reading first B, and stack top would be X. Stack top would be X here. So for valid string, stack top must be X. So how we would be doing it? Now we have decided to pop one element when we are reading B. So we will now change our state to Q1. We will now change our state to Q1 and we will we will pop one element from the stack. And this popping one element from the stack is mentioned as epsilon in stack string. So this would represent the popping one element from the stack. So this is how we can pop one element from the stack. And then after reading first V, we have changed our state to Q1. So in Q1 again, we can get next B. So in Q1, we can have B as input and X must be the stack top for valid string. So again then we can stay in Q1 and we can again pop one element from the stack. So for second B or third B, for any number of B's you can read from this particular transition. So suppose for this particular string second B is there, so we will use this transition to read this second B, and in this case we will pop one element from the stack. So this would be the removed, and now stack top is Z0. So after reading all B's, for valid string, you are in Q0, you must be in Q1, sorry, for valid string, you must be in Q1, you must be reading epsilon because your string is completed. So now in the next location, you will read epsilon here. So in Q1 for valid string, you must be in Q1 and you are reading epsilon, and in that case, Z0 must be the stack top. Z0 must be the stack top. So in that case also, you will stay in Q1 and you will pop Z0 itself. So when you are popping Z0, so this would also be removed from the stack, and after reading complete string, stack is completely empty. So this string is accepted by the PDA. So this is how these 5 rules you can create for that particular language. So I hope it is very much clear. Now I will make little change in this language, and here I have mentioned this condition here. Suppose in place of 1, if I make it 0, then what change you need to do in this particular PDA. So now for valid string, in this case again, you can see what would be the minimum string here. If the value of n is 0, then epsilon will be the minimum string. Epsilon will be the minimum string. And in this case, epsilon must also be accepted by the PDA. So for this, we need to add only single rule here, which is we are in Q0, which is initial state of PDA. And if n is 0, then we will read epsilon, and Z0 would be the stack top. Z0 would be the stack top. So this must also be accepted. So we will stay in Q, we will move to Q1 and we will pop this Z0 here, Z0 here. See, here changing state is not necessary. You can stay in Q0 or you can change to state to Q1. No problem is there. String will still be accepted. So this is how for that particular condition only one rule we need to add in this PDA, and this is now accepting epsilon also. So now friends, this is the next language that we will discuss. So now for this particular language, I will tell you the logic first, idea first, and I will take one valid string of this language as an example. So I will take A, B, 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 B. This string is valid string of this language. So how we would be doing it? See, you can see friend here for a single A we need to accept two B's. For each single A we need to accept two B here. So what we can do, as I told you friend, we can push more than one symbol at a time into the stack. So for each A, we will be pushing 2x here into the stack, 2x into the stack. And for each B, we will be popping 1x from the stack. So my idea is for this, whenever we are reading A, we will push 2x into the stack, and for each B, we will be popping 1x from the stack. So you can see how it works. So we will read first A here. So we will push 1x, 2x into the stack, and then we will push second A here. So we will push two more x here into the stack, and then we will read first B. So we will pop this x from the stack, and then we will read second B. So we will pop this stack x from the stack, and on for third and fourth B also we will pop both these x from the stack, and at that location we will read epsilon. So when we are reading epsilon, so there will be z0 on the stack top, so we can simply remove it, and in this way this particular string will be accepted by the PDA. So this would be the logic. So now according to our idea, I will create now the transition rules for this particular language. So as n is greater than or equal to 1 here, so minimum string would be there a b b, a b b. So it is not accepting epsilon. So we will suppose your starting state of PDA is Q0. So in Q0 you will read A, first A here, and when you are reading first A, then Z0 would be on stack top. So Z0 would be there in stack top. Then what we have decided? We have decided to push 2x into the stack when we are reading A. So in this case, we can write it, we will stay in Q0 and we will push 2x here into the stack. Along with this, we will write current stack top as it is. So I can see here, I can write it like this, xxz0. So this is how you can represent this transition. Now, when we are reading second A, when we are reading second A, and at that position, at, at that moment you will see x on the top of stack. So you are in Q0, you are reading A again, but this time x is there on the stack top. So again, as per our logic, wherever you are reading A, you need to push 2x into the stack. So I can stay in Q0, I will push 2x here, and current stack top I will mention as it is. So this is how you can represent this transition. Now, when you are reading 2x, so you will, second A, so you will push 2 more x into the stack. And then, according to this particular string, when you are reading first B, you will be in Q0, because after reading A, you are not changing your state, so you will be in Q0. And Q0 itself, you will read first B. So when you are reading first B, then at that time X must be the stack top for valid string. So X would be on the top of a string. And then when we are reading first B, so we will pop one element from the stack. Now we will also change the state Q to Q1, and we will pop one element from the stack. So according to this particular logic, we will remove one x from the stack. When you are reading first B, so when you are reading first B, you will be in Q0. And after reading first B, as you have changed your state to Q1, so next B you will read in Q1. So you are in Q1 now. You will read second B, and at that time also, uh, X must be stack top for valid string. So again, you will stay in Q1 and you will pop one element from the stack. So now any number of B's you can read from this particular transition. Now, after reading all 4 B's, you will remove all 4x from here, and when you read at the end, you will read this epsilon. So you will be in Q1, you will read epsilon, and at that time Z0 would be the stack top. Z0 would be the stack top. So now you can pop this Z0 also, and you are reading epsilon and your stack is empty now, as you have popped this Z0 also. So after reading complete string, your stack is completely empty. That means string is accepted by the PDA. So this is how you can create PDA for this language. I hope this would be very much clear. Now I will make little change in this particular PDA. Now in the language, if I'm writing n is greater than or equal to 0, so this in this case, this language will also accept epsilon, and in the case PDA is accepting epsilon, then in initial state which is Q0 here, it must read epsilon, and at that time Z0 must be the stack top, as it is initial stack symbol. So in that must also be accepted. So I can write Q0 and epsilon here. So if directly we are reading epsilon in Q0, then this Z and Z0 is the stack top, then it will be popped from the stack and your string will be accepted. So only this rule you need to add to make it 0 and 0. So this is how you can create PDA for this particular language. I hope this would be very much clear to all of you. Now I will take third language as example. So now, friends, this is the third language for which we will create PDA now. Now, according to this language, a valid string would be AA, AA, BB. This would be the valid string from this language. Now, as you can see here, the number of A are double of number of B's. And as in previous example, we have seen we can push more than one symbol at a time, but we can pop only one element from the stack at a time. So now, if we push only one symbol here for A, X as X, So 4a would be pushed into the stack. But we can now push only one element from the stack. So for 2b, we will be popping 2x from the stack. Then still 2x will be there in the stack and stack will not be empty. So for this particular language, we need to create some different logic. So can we do it like this? Like for 2a, for consecutive 2a, if we are reading, then we will push only one x for into the stack, so that for each pair of a, we are pushing only one a there. So we will be like for this particular pair of A, we will push one X. For this particular pair of A, we will push another X. Then for this this B, we will pop this X. And for this B, we will pop this X, so that M stack will be empty. So this is how we can implement this. Now, how we will be doing it, that we will see. So for this particular logic, we will how we will be creating the transition, that you can understand now. Now, when we are reading first A of each pair, then we will only change the state. We will not push any symbol into the stack, or we will not pop any symbol from the stack. We will only change the state. So now suppose your initial state of PDA is Q0 and you are reading A. Then when you are reading first A, then stack top must be Z0. So as I told you, when we are reading first A of pair, then we will only change the state. We will not push any symbol into the stack, or we will not pop any symbol from the stack. So we will change the state to Q1. If we are not popping or pushing any element, we are not performing any operation on the stack. So we will take this Z0 as it is to the right hand side. That means we are not pushing any symbol into the stack, or we are not popping any symbol from the stack. So this is how you can represent this. Now, on Q1, we will be reading second A of each pair. So when we are in Q1, we will be reading A and still Z0 on the top of the stack. So this time I can switch back to Q0 and I can push one X into the stack like this. Now we have read first two A here for first pair of A. Now we have read first pair of A. For first A, we have changed only the state, and for second A, we again back to the initial state and we push one X into the stack. Now, when we are having another pair, so for 2A, after reading 2A, we have pushed one X into the stack. Now, we are on Q0 again. So on Q0, we will be reading A again, and this time X would be on the top of the stack. So I can write it like this, and then according to our logic, we need not to push any symbol into the stack. We need to only change the state. So we will move to Q1 again, and we will keep stack as it is. So now this is how we can read third A. Then we are in Q1, and we are reading fourth A here. Now again, stack top is X. Now what we will do again? We will switch back to Q0 again, and we will push one more X into the stack. So this is how we will push one more X into the stack. So for 4 number of A's, we have pushed only 2X into the stack. And now after this, these two these two rules you can use to read any number of pair of A's. Now, after reading all A's, we will read first B. So at that time, for validation, we must be in Q0. So on Q0, you will be reading first B and stack top must be X at that time. So what we need to do according to our logic, for each B, we will remove one X from the stack. So we will change our state to Q2 as we have already used Q1 here. So now I will change our state to Q2 and I will pop one element from the stack. So now we will remove, after reading first B, we will remove first X from the stack, uh, then 1X from the stack, and then after reading first B, we have changed our state to Q2. So now we will be, for another B, we will be in Q2, we will be reading B again, and the stack top must be X for validation. So in this case also, I have to stay in Q2 and I need to remove this X. So I will pop one more element from the stack. And then after this, using this rule, you can remove all number of B's. You can read all number of B's there. Now, after reading all B's, we will be reading epsilon here. We will be reading epsilon here. And we will be in Q2 at that time. So we can write Q2. We are reading epsilon and the Z0 must be on the top of the stack for validation. So Z0. So now if this is the situation when we can stay on Q2 and we can pop this X also, Z0 also, and after reading complete string, stack is completely empty. So that means your string is accepted by the PDA. So this is how you can make it accepted by PD. Now, again, we can take one change here, like we can make it 0. So if we are making it 0, then it will be accepting epsilon also. So in this case, again, the same rule we need to include. We will be in Q0, which is initial state. We will be reading Z epsilon, and Z0 is the stack top. So in that case also, we need to stay in Q0 and we will need to pop Z0. So in this case also, this will accept epsilon also. So this is how you can create PDA for this family of a string. Now suppose you have A, 3n, Bn, then what you will do? So for 3a, you need to add only one X into the stack. So uh, for any triplet of A, for first 2a, you will change only the state. You will not push in any symbol into the stack. So instead of Q1, you can use Q1 and Q2, and then you can go back to Q0 and push one element into the stack. So this is how you can create any number of A there, as this is general logic for this kind of language. So I hope this would be very much clear. Now, till now, we have seen all the PDA design accepting strings by empty stack. Now, it is very much simple to convert this particular PDA into PDA accepting strings by reaching final state. So now how you would do it? So I can create, now I will make little change in this particular PDA and it will be converted into PDA accepting strings by reaching final state. So now you can see this last rule here when we are reading, when we are popping Z0. So we are staying on Q2. So Instead of staying in Q2, we can change our state to Q3, and Q3 would be your final state. Q3 would be your final state, and you can pop this Z0, or you can simply take Z0 into the stack, keep Z0 into the stack, so that once you reach Q3, that means string is accepted. Whether stack is empty or not, it doesn't matter at all. So only by changing the last rule, you can convert any PDA accepting strings by empty stack into PDA accepting strings by reaching final state. So I hope this would be very much clear to all of you. And in previous example we have discussed already, so you can use the same technique to convert it into PDA, which is accepting strings by reaching final state. So I hope you can do it now very easily. So friends, this is the next language that we will discuss how to create PDF for this. So I will tell you first the idea. So in this particular language, your stack would be there and it will be containing Z0 only, which is stack's initial stack symbol. And you can see here, you can notice one thing here, we need to count the number of A so that we can have same number of C's, right? So there is relation between number of A and number of C only. Number of B, we can have anything. We can there is no relation between number of A and number of B, and number of B and number of C. So we need to check only the number of A's and number of C. So now for this, how we can do? So for that particular language, I can have a valid string as A, and you can see M and N both are greater than or equal to 1. That means N and M, the minimum value would be 1. So minimum string of this particular language would be ABC. ABC. But you can have A, C, A, B, C, C, A, A, B, C, C also. So this is the one valid string here. Now, how we would be creating PDF for this, that we will discuss. So I'm telling you first idea, like for each A we are reading, we will be pushing one element into the stack, which is consider it as X. And then for each B we are reading, we will do nothing we will not perform any operation on the stack. So X will remain in the state for all number of B's. We will only read the B and do nothing on the stack. And when we are reading C, then we will start popping one element from the stack. So in this case, if we are having same number of A and the same as the number of C's, so for all A's we are pushing one element, and for all C's we are popping one element from the stack. So after reading complete a string, Z0 must be on the top. So this is how we can ensure the same number of A and number of C's. So now we will create logic for this. So now suppose your initial state is Q0. You are reading A. First A you are reading here, and at that time Z0 would be on stack top. So in this case, what we have decided according to our logic, we need to add one X into the stack. So we will stay in Q1, Q0. We will push one X into the stack like this. So this you have read first X. Now you will read A again. You are in Q0. You will read A again, but this time X is on the top of the stack for valid string. So I can make one transition for this also. So I Q0, then X, then X. So we have pushed one more X into the stack. So I can write it like this. Now, any number of A's you can read from this particular transition. Now, you will read first B. So, as we have decided not to perform any operation on the stack while we are reading B. So, we will change the state on B and we will remain in the same state while we are reading B. Right? So, we are on Q0 when we are reading first B. So, we are on Q0, we are reading B and stack top is X. And in this case, what we are doing, we are just changing our state to Q1 and we are doing nothing. So we are simply copying the current stack top on the right hand side. So we are just changing the state. We are doing no operation on stack. Now, as we have changed our state to Q1, so on Q1, you can get B again. So on Q1, if we are getting B, and the stack top is still X, so I can stay in Q1 and I can keep stack as it is. So now for all these you can use this rule. Now on Q1 you will read first C. On Q1 you will read first C, and at that time X would be the stack top for valid string. So what you will do when you are reading first C, for all C, you are popping one element from the stack. So you will change your state to Q2 and you will pop one element from the stack. So after reading first C, you will remove this X, and then now after reading first C, you have changed your state to Q2. So on Q2, you can have another C for valid string. So you can have another C. At that time also, X would be the stack top for valid string. Now, you can stay in Q2 and you can pop one element from the stack. So after reading second C, you will remove this X also. Now, you can use this rule to remove any number of C's there. Now, after reading complete C or after reading all C, string would be completed and you will read epsilon there. And for valid string, when you are reading epsilon, you must be in Q2. Then you must be in reading epsilon and Z0 must be the stack top there. So now you can stay in Q2 and you can remove this Q0 Z0 from the stack. So after reading complete string, this Z0 would also be removed. So string is accepted by the PDA. Now these are the rules you can create for making this language accepted by the PDA. Now again, if you want to make it to convert PDA accepting strings by reaching final state. So what you can do here, instead of staying in same state, you can change your state to Q3 and your final state, set of final state would be containing Q3. So this is how you can convert it to PDA accepting strings by reaching final state. Now, as we have two variables here, m and n. So both for condition for both may be same and may be different also. So if your m and n both are greater than or equal to 1, so we have seen the transitions already. Now suppose m is greater than or equal to 0 and n is greater than or equal to 1. So in this case, number of B may be 0 also. Number of B may be 0 also. In this case, on Q1, or when you are reading first B, you are on Q0. When you are reading first B, so you are on Q0 and the stack top is X. So you are in place of B, you can directly get C here. You can directly get C here. So you need to one more, you need to add some more transition on like this. On Q0 you will read C and stack top would be X, and at that particular combination you can pop one element from the stack as you are reading C. So this is now I will not make I will not add that that transition rule here. You can practice it yourself. Now I will take another next language as example. So now friends, this is next language which is having four input symbol, A, B, C, and D. And now you can see this in this language we have a relation between the number of A and number of B, and as well the number of C and number of D. Now we have the relation between the number of occurrences of two symbols only. So one pair is A and B, and another pair is A, C, and D. So now what we can do here, my idea is Z0 would be the initial stack symbol already in the stack. Whenever you are reading A, you will push one symbol X into the stack. And whenever you are reading B, you will pop one symbol X from the stack. And if the number of A and number of B are same, then when you are reading first C, then Z0 must be on the stack top. So in this way we will ensure the number of A and number of B are same. Now when you are reading first C, Z0 would be on the stack top, and at that time when you are reading stack first C, you will push one element Y into the stack. For each C, you will push one element Y into the stack, so that you will have any number of Y there into the stack, and then once you start reading a D, you will start popping Y from the stack. So for all number of D's, you will pop one Y from the stack. So if number of C and number of D are equal, then after reading complete string, Z0 must be on the top of the stack. So if this is the condition, then you can consider this string as accepted by the machine. So now I will create transition for this. So I can take any valid string for this. So A, B, B, C, 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 D, D, D. So this is one valid string for this language. So now you can see here the minimum string would be there A, B, C, D, because the number of A and number of B may be greater than or equal to 1. So this is one valid string for this particular language. So now we will again start with Q0, which is our initial state. So on Q0, you will read first the A, and at that time, Z0 must be stack top. So according to our logic, we have decided to put one X into the stack. So we will stay in Q0, we will push one X into the stack, and Z0 would be copied as it is. Then on Q0, we will read second A, and at that time X would be on the top of the stack. So we need to push one more X into the stack, so we can represent it like this. Now we can push and we can read any number of A's using this rule. Now after reading first B, so we must be in Q0. So we are in Q0, we are reading B, stack top is X, then we must change our state to Q1, and we must pop one element from the stack, which is obviously x. Now after reading first B, we have moved to state Q1. So on Q1 we can have second B. So at that time stack top must be x for valid strings. So what we can do, we can stay in Q1 and we can pop one element again. Now after reading all these, we will have C. We will be reading C. So on Q1 we will be reading first C, and at that time stack top must be Z0 for any valid string. Now here what we will do, we will move to next state Q2 and we will push one Y into the stack, and then we will on Q2 we will get next C. So on Q2 we will get C again, and at that time Y would be on top of the stack. And then we will push one more, we will stay in Q2, we will push one more Y into the stack, and then you can read any number of C using this rule. Now on on Q2 you will read first D, and at that time Y must be the stack top. So I can write it. So whenever I'm reading first D, I can change my state to Q3 and I can pop one element from the stack. And then on Q3, you will read second D. So I can be in second Q3, I will read a D, and I will stack top must be Y. So in this case also, what you need to do, you need to stay in Q3 and you need to pop one element from the stack. And then after reading all, you can read all number of D's from this rule. Now after reading all D, you will read epsilon, and at that time Z0 must be the stack top for validation. So I can write here one rule there, Q3, and you are reading epsilon, and then Z0 must be the stack top. So in this case, what you can do, you can remove this you can stay in Q3 and you can remove this Z0 from the stack. So when you are reading epsilon, stack is also completely empty. So that means this string is accepted by the PDA. So now again, you can have any combination of conditions here. Here we have considered m and n both greater than or equal to 1. So both may be greater than or equal to 0. In that case, it will be accepting epsilon also. So accordingly, you can add one transition rule there. So for all valid strings, we must be able to write all possible combination for valid strings. So I hope this would be very much clear. Now I will take next language as example. Now friends, this is the last example language that we have taken here. So you can see here again we have 4 input symbol here, but again we have relation between 2 symbols only at a time. So like we have relation between A and D and B and C. So these 2 things we have. So this language is different from this, right? So now we cannot have relation between the number of occurrences of more than 2 elements in context-free languages. So now here we have only 2 variables, 2 symbols where the relation is A and D and B and C. So now how we can create PDF for this, that we will understand. Now what our idea is, so when we are reading A, we will push one X into the stack. We will push one X into the stack, and when we are reading B, we will start pushing Y into the stack. We will start pushing Y into the stack. Now when we are reading C, we will pop Y. When we are reading C, the stack top must be Y, And if it is y, then we will pop this y from the stack. And when we are reading a d, then stack top must be x, and if it is x, then we will pop this x from the stack. So after reading complete string, both x and y must be removed and z0 must be on the top of the stack. So if you are getting, if we have same number of a as same number of d and same number of d, then we will not have any x left in the stack. If we have same number of b and c, then we will not have any y left into the stack. So in this way, we can ensure the same number of occurrences of a and d and b and c. So now I will write transition rules for this. So again, I'm considering you are on Q0, which is initial state of PDA. So Q0, then you are reading first A layer. So you will be in the stack top will be Z0. In this case, what we have decided? We have decided to put one X into the stack, push one X into the stack. So I will stay in Q0. I will push one X into the stack, and then on Q0 again you will get second A. So on Q0 you are reading A again, but this time X would be on the stack top. So I can write one more transition for this combination. Now you can see I can stay on Q0. I can push one more X into the stack like this. So now you can read any number of A's using this rule. Now on Q0 we will read first B. So on Q0 we will read first B, and X must be the stack top in for valid string. So when we are reading B, so according to our logic we will start pushing Y into the stack. So I can write, I will change my state to Q1 and I will push one Y into the stack. So this is how I can represent this particular transition. Now, after reading first B, we have changed our state to Q1, and in Q1 we can get another B. So on Q1 you will get B, but this time Y would be the stack top for valid string. Then you can stay in Q1, you can put one more Y into the stack. Now, after reading all, you can read any number of B's from this rule. Now, on Q1, you will read first C. So, on Q1, you will read first C. Then, stack top must be Y at that time. So, now I can change my state to Q2 and I will remove this Y from the stack as per our logic. Now, after reading first C, I have changed my state to Q2. So in Q2, I can have another C. So if more than one C's are there, then you can have another C on Q2. So when you are on Q2 and you are reading C, and the stack top must be Y for validation. So I can stay in Q2 and I can pop one Y again. So you any number of C you can read with this rule. Now on Q2 you will start reading D. Then stack top C. If number of B and number of C are same, then on first D, all Y's must be completed. All Y's must be removed from the stack. So stack top must be X for valid string. So in this case, you can change your state and you can pop this X from the stack. And then on Q3, you can have other number of D's. Second D you can consider. So I can on I will be in Q3. I will be reading a D, and Again, for valid string, X must be the stack top. So then you can on again remove this X from the stack. So you will stay in Q3 and you will remove this X from the stack. Now, after reading all D, you will be reading epsilon here. Now, when you are reading epsilon, then stack top, if A and D are same, then stack top must be Z0 only for valid string. So, on Q3, if you are reading epsilon, then stack top must be Z0. So if it is this combination you are getting, you can stay in Q3 and you can remove this Z0 from the stack. And after reading complete string, you are reading epsilon and stack is completely empty. So string is accepted by this machine. So this is how you can write all the rules for any language. So I hope this is very much clear to all of you. Now, if you have any doubt, you can always write to me in comments and I will definitely reply your comments. Thank you. Thank you so much.